We've got 6 presentations, so we're going to be about an hour, and then we're a little bit delayed, so probably only 20 minutes of questions. It's quite interesting and exciting to be part of this measurement group. Seeing the presentations here, we're all working towards very similar goals. It's quite exciting for me. We're going to have Marko talking about his experiences with testing wind turbines, and Raphael is going to talk about his experiences with monitoring and data acquisition. And then we've got Jill, Matt, Tom, and Lewis, and we're all talking about similar takes on data logging and our ideas and designs for that. So I'm looking forward to an exciting working group, small group session. So I'm going to hand over now to Marko, who is going to be the first presenter.
Okay. Thank you all. Yes, I'm presenting the work that we've done on testing our wind turbines on a semi-official test field in the Netherlands. You see here the Netherlands, it's not over here. In part of the Netherlands should be very windy, but I'll come back to that later. I will talk to you about a little bit of the site, because that's very important, of the measurements of the performance of the 2 turbines. We tested a 1.8 meter turbine and a 2.4 meter turbine. And the good thing is we could compare it to a lot of commercial turbines which are on the market and dared to put their turbine on the test field. There's also a little story behind it why we got the opportunity to go on this test field, is that there were some empty spaces there. There used to be completely full and used to be very ambitious of putting this test field, and there were a lot of customers want to have their wind turbine there. But after a short while, many wind turbine manufacturers find out that the performance was not according to their brochure that we were selling these turbines by. This field was kind of public. The performance data out of it, the reports out of it were public. So actually some turbine manufacturers actually withdraw because they were not satisfied with the results of their own turbine. Some wind turbine manufacturers went bankrupt. I don't know because of this, but it didn't help. So what was left there were a bunch of turbines. I'll come back to that later, and our turbine standing here. First, a little bit about the site. You saw a lot of presentations of people having wind maps and stuff. The Netherlands, we have the same. You see here the red spots, perfect wind conditions in the Netherlands, above 60 meters per second average on 10 meters. This is a 10 meter high map. So from our Royal Weather Institute, so pretty reliable. But the resolution of this map is about 2.5 kilometers, and that makes sense because here you see the Google map of the site. This is these are the wind turbines. These are ours. This is north, south. Typically, the high wind and the average wind direction is south-southwest. And what happened? We have a lot of village here. We have open landscape over there. You see this picture above is taken from the city towards the fields, and the city actually, it's my opinion, was blocking a lot of wind because they were expected about 6 meters per second on an average, and it was actually measured on a benchmark somewhere north of this site, not far away, it's a couple of kilometers. And typically on that side, the average wind speed that we measured was 3.8 meters per second on a yearly basis. And that's what the Royal Weather Institute gave as a number for specifically this site, was 5.2. In my opinion, it makes sense if you are south of the city or village, it's a small village, or just north, and because of the wind direction. So actually, location matters, all the details matter, especially when you are at our mast was about 15 meters high. You have a lot of noise on houses, trees, and all kinds of obstacles. So don't rely on just maps or other stuff. Okay, this is one of our first pictures taking on the test fields. What we did, we were all volunteers here and we have not much money, so we were really lucky to get a big tower that was there, which was not in use. So I said, okay, good, we get a tower for free, but it was a huge one. You see it there. I think it was 1,500 kilos or so, whatever, very hard to handle. But finally, we managed to handle it. We came with a turbine, but the turbine wasn't that big of a problem. The tower. Yes. Finally, what we did, we made some kind of a hinge structure to hinge that big thing, to maintain it, to get new turbines on and off, and all this kind of stuff. Normally we don't use these big towers. So, yeah, here you see how we erected. Yeah, it's pretty hard work, but our terraformers did it. So, okay, going alive with all kind of steel structure that we're building, and it was, yeah, it was hard, but okay, we did it, and it was spinning for about half a year. Our first turbine was a 2.4 meter turbine. It was spinning in summertime, and if you see the wind average, it's in the Netherlands in summertime we have low wind, and in winter we have high wind. So actually, from June to November, it saw an average wind speed of 3.6 meters per second. But what we saw directly, actually, from the data that we got from this test field, which is actually a luxury for us, that we could make use of official wind measurement on two places, two heights. We have all the data real time via the internet, and could see also the comparison to all the other turbines at real time. So yeah, the first thing what we saw when this turbine was spinning, that the cut-in speed was much lower than all the other ones. So at low winds we were producing energy, and all the rest was standing still. So that's one thing that we learned about Hugh Piggott. It has a pretty low cut-in speed.
Is it battery coupled?
No, it's grid connected.
Grid.
Yeah. This one was connected with a really boy inverter. And what we could do is we could compare it to all the other turbines, and I will not draw all the names of it, but I have some pictures later. Draw your own conclusions. But what I did during this period that the wind turbine was installed, I just compared the amount of energy produced and divided it to the surface to make a fair comparison. And what you see our turbine, this one pretty high up. If you see the yield divided to the square meter of the one. There was one turbine, one southwest wind power, the Sky Stream. Okay, and tell you that when it is working, it's performing well. What you see my next slide, that also commercial turbines break down, and on that test field a little bit more often than ours. But finally, this one also broke down. I'm not sure if I have a slide on that. No, I don't have a slide on that. But in November, the first storm hit the Netherlands, which were gusts about 25 meters per second or so. And what happened during the furling is actually we did something wrong in designing in building it. The blades could hit the tail, and it did. Broke a blade tip, and then all kinds of strange things happened. And actually, I have to hurry. So we want to have it a 6 month period of testing, because then we could finalize a duration test more or less officially. We had almost 6 months of testing. We derived power curves out of it. I will skip that because a little bit earlier than planned we put it. Yeah, this is actually the damage I want to show you. The blade hit here, exactly that location. Then we could install our second turbine, which is a little earlier. Here you have Pete. We learned. Now you see it in a fully firm position. The picture below, the tail couldn't hit the blades anymore. It's just you have to take care of the steel piece of the tail. We did the same comparison. You see here it was actually the best on the field. At that period the SkyStream was out. But you see you have really poor performing wind turbines here. So, actually, I have much more data on it. The nice thing is of this 1.8 turbine is it was running during winter, so the average wind speed was much higher. It's 4.8 for that period. So actually it performs really well and produces a lot of energy, even for a small wind turbine. We did power curves. Also, CP values is actually for this turbine was a little bit better than the 2.4. I want to avoid the chicken, but the only thing I can conclude out of our testing is, please, but you know all that. Do not buy one of these. Build one yourself. It's much simpler, cheaper than
Wonderful, wonderful. Don't buy any of these.
I don't know. I have no idea. Yeah, you should ask him. We can ask him right now.
Or the Q&A.
Okay, good afternoon once again. My name is Rafael Oliva. I want to talk about experiences in measurement systems for wind power and small grid systems. I am very thankful to Wind Empowerment for this invitation. I am talking. I belong to the Universidad. It's a university in the south tip of Patagonia. You know where the continent ends. So we are in a very windy zone. It's quite harsh in the winter, and we do have problems as shown here with